In today's video, we're going to talk about divergent boundaries. There are three types of boundaries when we talk about plate tectonics: divergent, convergent, and transform. So obviously, when we're talking about divergent boundaries, as you can see here, we're talking about things that are moving apart. So the popular movie and book series, Divergent, is all about different groups of people that are segregated and they're kept apart. So everything, when we talk about divergent, is about things moving apart in opposite directions. The first type of divergent boundary that we're going to talk about is a rift valley. So if you look here, this is the Great African Rift Valley, and it moves right through this part of Africa right here. And you can see that Africa is actually being torn into uh, different sections. So they're pulling apart, and it's literally tearing Africa apart. This has happened actually a few places before in the Earth already. If you look down at Madagascar, right down here, it's been torn away from Africa. So these processes keep happening again and again. So again, divergent boundaries moving apart. So if we were to look at these two continental plates, so for a rift valley, we're talking about two continental plates that are moving apart. Now, what would we expect happen if the plates were moving apart? Right here, you're going to be exposing the magma that's down here in the asthenosphere, So that magma down here in the asthenosphere is going to start to rise up once they tear far enough apart. So we would expect that we would see some volcanoes starting to happen along this rift valley. And if we look back on this map, you can see that each one of these triangles is just that. It's a volcano forming. You're also going to see that there are some spots where it maybe hasn't torn all the way down to the asthenosphere yet. So right in here, the Earth has pulled away, and you end up with some lakes that are starting to fill in. So here you can see Mount Kilimanjaro, which is a large volcano that's formed when it's torn far enough apart that the magma is starting to rise up. And here you can see a lake that's forming right across that rift valley. The second type of divergent boundary is seafloor spreading. So here you can see we have continental plates and the oceanic plates that are sitting beneath the ocean, obviously. So what's happening is these oceanic plates are being pulled through convection currents that are deep in the asthenosphere. So the asthenosphere rises, moves to the side, and falls. And as it does so, it's dragging these oceanic plates, and so it's moving them apart. Now, we would expect there wouldn't be a gap in the ocean, so when that hot magma rises up here at this gap right here, it's going to form a ridge, and you're going to have some underwater volcanoes as these oceanic plates are pulled to the side. All right, so the question is, where would we find the newest ocean floor being formed? All right, and so what we see is, since there's volcanoes being formed and magma coming out, the new ocean floor would be expected to be found near the center of the seafloor, and the older is going to be out here towards the edges of the ocean. Now we see this happening in specific in the Atlantic Ocean. We have this mid-Atlantic ridge that runs the full length of the Atlantic Ocean. And this is the ridge that Henry Hess discovered when they were first proving that continental drift was happening. So what actually proved continental drift is they found that the ocean floor near the center was new and out here was old. And that proved once again that the ocean floor was spreading and the continents were therefore moving. So we would expect, if we were able to, with greater technology, to go underwater, we should be able to see some underwater volcanoes occurring. And this is exactly what's happening right here. This is a picture taken by a remote submarine along the mid-Atlantic ridge, and we can see that this underwater volcano is erupting. It's turning the water immediately to steam, but before that steam can ever reach the surface, it's condensing back into liquid water. So we never have any clue about the chaos that's going on underneath us in the Atlantic Ocean. Iceland is actually located right along the mid-Atlantic ridge and is being torn apart. Half of it going with the Eurasian plate, the other half going with the North American plate. This woman right here is actually walking right along the mid-Atlantic ridge. So this part of Iceland is going this way, this part of Iceland is moving this way. And as you would expect, if the island was being torn apart, you would have volcanoes forming. And there are a number of geothermal activities and volcanoes all over Iceland. It's actually been a very good thing for Iceland. Iceland is actually able to use all that energy provided from the steam of these volcanoes and these vents to use it to make their own electricity, making them one of the most energy independent countries in the world.